In this video, we're going to look at a second way that we can solve exponential equations, and this is going to be using the definition of a log. So we looked at this definition in a previous video when we first started looking at logs, and that tells us that if we have an exponential equation, b to the power of x is equal to y, then we can rewrite this as an equivalent log equation. The log base b of y is equal to x. So we're going to use the definition of a log to solve equations when we're not able to use the one-to-one property. So if you cannot write both sides of the equation as a power of the same base, then you'll use the definition of a log instead. So let's go ahead and take a look at this first example here. 3 to the power of x is equal to 30. So looking at this, the reason I know that I can't use the one-to-one property is because 30 is not a power of 3. Okay, if you think about your powers of 3 for a second, 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. Okay, but we don't have a nice whole number exponent that's going to give us a 30. Okay, so we're not able to just rewrite this like we were the ones in the last video. Instead, we're going to change our exponential equation into a log equation by using that definition. So if we change this into the equivalent log form, this would become the log base 3 of 30 is equal to x. Okay, now that is going to be our exact answer. We can also, though, get a decimal approximation by plugging this into our calculator. In order to plug this into our calculator, though, we're going to have to use the change of base property, which we talked about in a previous video. Let me just remind you of that real quick. So our change of base property, if you recall, told us that the log base b of x is equal to the log of x divided by the log of b. You could equivalently use natural log here if you prefer, but it doesn't matter as long as you have the same log on the top and bottom. So our log base 3 of 30 then, we can rewrite as the log of 30 divided by the log of 3 using that change of base property. And then this we can just plug into our calculator. So remember, your log button is just over on that left-hand column if you're using a TI-83 or TI-84, right next to the 7 key. And you're just going to punch it in just like that, and you'll get approximately 3.096 as your answer. So again, this right here, this is our exact answer, and then this would be our decimal approximation. So depending on what you're asked for in the problem, you'll have to think about which answer you want to give. Okay, so let's go ahead and take a look at a few more examples like this. So next we have 5 times e to the power of 2x is equal to 60. All right, now on this one, you'll notice that we have this 5 out front to begin with. So before we can use our definition of a log, we have to isolate the exponential term, meaning we have to get rid of this 5. So in this case, since the 5 is multiplied to the exponential term, we'll divide by 5 on both sides, which gives us e to the 2x is equal to 12. All right, once you isolate the exponential term, then you can switch it into log form. And remember that the log with a base of e is the natural log. So this becomes the natural log of 12 is equal to 2x. All right, solve for x, so divide by 2 on both sides. And we end up with x is equal to the natural log of 12 divided by 2. Okay, so that is our exact answer. And then if you want a decimal approximation, you can just plug that into your calculator. There's no need to do the change of base property on this one because we have a natural log button right on our calculator. It's right below the regular log button. So just punch that in and we would come out with approximately 1.242. So that would be our decimal approximation. Okay. So the idea I want you to see in this one is that before you can use the definition of a log and switch into log form, you have to first isolate your exponential term. All right, so let's try this one last. So we have -3 times 7 to the power of 8x plus 8 plus 3 equals a -90. All right, so once again, in order to use the definition of a log and switch this into log form, we need to first isolate our exponential term, okay? So in order to solve this equation, in order to isolate that, we'll want to start by subtracting 3 from both sides. Which will give us -3 times our exponential term is equal to a -93. Then divide by -3 on both sides, which would give us 7 to the power of 8x plus 8 is equal to 31. Once you've isolated the exponential term, then you can switch it into its equivalent log form, which would be the log base 7 of 31 is equal to 8x plus 8. Now we just need to isolate x. So subtract an 8 from both sides. Log base 7 of 31 minus 8 is equal to 8x. And then divide by 8. So x is equal to the log base 7 of 31 minus 8 all over 8. All right, so that is our exact answer. If you want a decimal approximation, again, you can use your change of base property, so you can plug this into your calculator. So our log base 7 of 31, we can change to the log of 31 divided by the log of 7, and then we still have the minus 8 divided by 8. And you'll probably want to plug that into your calculator in a few different steps so that you're not playing too much of the parentheses game. But once you get that plugged in, you will eventually get -0.779. Again, this is our exact answer, and this is our approximate answer. All right, guys, so there are a few more examples worked out in the notes that I posted on Blackboard. If you want to see more, take a look through those. But otherwise, we're going to end our video here, and in the next video, we're going to take a look at solving log equations.